we need to find all g of x, which are elements of the real numbers, such that g of x minus L, the absolute value of that quantity, is less than some epsilon, where epsilon is greater than 0. So we're not given what epsilon is, we just know that it's a positive number. So how are we going to find the interval that satisfies this with all these variables? The guy that we're looking to solve for is g of x. Okay, that's the guy we want to know what interval it has to be on. The interval is going to involve L and epsilon. Okay, so we've got two ways to set this up. The first way is to look at this on a number line and to think about this as distance. So we have some fixed value L. Okay, L's some real number. Okay, now it's not explicitly set in here, but it's understood. So we could also say, okay, L is a real number as well. So we're looking for the distance of g of x and L, and we want that to be less than epsilon. So g of x is the guy that gets to vary. L is fixed, and for right now, epsilon, we're going to consider that a fixed value. Okay, it's stuck. So what this says, if we have a number line, well, here's L, and the distance, g of x, is somewhere on this number line. We don't know where it is. Okay, let's just pretend it's here for right now. We'll pick an arbitrary spot so that you can visualize this. We need g of x to be close enough to L so that its distance between g of x and L is less than some epsilon. So let's draw in, let's let epsilon be equal to, it's some number. Okay, it's a real number. Okay, and we're going to just, I'm going to let it have some distance. Okay, right? Every number has a distance from 0, correct? If you think about it, like 5 is 5 units away from 0, or negative 3 is 3 units away from 0. Epsilon is epsilon units away from 0. Okay, so this length here is epsilon. So if we go out this way, epsilon, we'll start at L, so if we go out a distance of epsilon, then this point must be L plus whatever epsilon is. Likewise, if we go that same distance the other direction, okay, if we subtract epsilon, we end up with L minus epsilon. And g of x has got to be stuck on that interval. So it's pretty easy to write now. What we have is that L minus epsilon is less than g of x, which is less than L plus epsilon. Or, okay, so this is within our inequalities. We could write the same, really what we're writing, this white line is really this blue line, right? Where we don't include the endpoints, because it's strictly less than. So this guy right here is the answer. We can also write this using interval notation, and we go L minus epsilon to L plus epsilon. We don't include the endpoints. And of course, g of x is an element of that interval. That's one approach. Another approach, okay, we'll do this in purple. So another way to get that same value would be to remember how absolute value works. So if g of x, so we've got two cases here, right? We've got case number 1 and case number 2. So let's look at case number 1. Case number 1 is that g of x minus L, if the inside guy here, this guy is positive. If that's positive, well, what would that look like? Well, where would g of x have to fall? Well, g of x minus L, for it to be positive, g of x would have to be more than L, which means it would have to fall over on this side. Okay, and that's certainly possible. G of x could fall anywhere on this interval, so it could fall over here. So if it's positive, then we can just drop the absolute values. Notice that what I got right here, g of x minus L less than epsilon, Okay, if I add L to both sides, I get g of x is less than L plus epsilon. Where do you see that? Right here. Do a different color here. So now let's look at the other side. The other side is that we still have g of x minus L, absolute value of that less than epsilon. However, in this case, what if it's not positive? What if it's negative? For it to be negative, g of x would have to fall over here on this side. Again, certainly possible, right? Because we're looking at distance, so it can fall to the left or the right of L. Now, if it falls to the left of L, and this is negative, then to get rid of the absolute values, we have to put a negative out front. Whoops, we need that to be a parenthesis. If I multiply everything by -1, I get this. Okay. And if I start moving some things, whoops, this should be negative, this should be positive, or excuse me, this should be negative. And if I move my L over, I have g of x is strictly greater than L minus epsilon. Where do you see that? G of x is greater than L minus epsilon. So if you put this guy together with this guy, you get this guy as well. So again, there's two approaches to looking at this.